Okay, this video is the review for Module 19, which is the probability. I'm just going to go through each problem here. Shouldn't take too long, but fast forward through to the one you want, or the ones you need. Number one, I probably shouldn't have asked it in how many possible combinations. It's a simple, basic counting problem. He's got two choices. He's got the size of the balls, and there are 3 different sizes, and he's got 5 different colors. And the result is there are 15 possible different balls that you can have. All right, number 2 is also a basic counting probability. You're using the digits from 9 different digits. So you've got 3 choices for this block, and you've got 9 choices times 9 choices, because it doesn't say anything about not being able to repeat, times another 9 choices. So you get 729 different possibilities. All right, number 3 is a combination problem. It's a combination of 6 things taken 3 at a time. So just for a quick refresher, that would be 6 factorial all over 6 minus 3 factorial times 3 factorial. And that should give you 20. Like I said, I'm going through these real quickly. If you have anything further that you need to see after this, please let me know in Google Classroom, and I'll be able to do it for you there. Number 4 is a permutation. And you have 13 things to choose from, and you are picking 4 of them. So again, the formula for that will be 13 factorial all over just the 13 minus 4 factorial. And that's the difference between permutation. You don't take out the other 4 factorial as you do in a combination. And that will give me 17,160. Number 5, we've got a word bookkeeper, and we're just going to find how many possible ways we can arrange those letters. And there's repeats of those letters, so if I would interchange the 2 O's, it really doesn't do anything. So I've got 10 total letters that I'm dealing with, so it's going to be 10 factorial, and I need to divide out my repetitions. So I've got the letter O that repeats 2 times, so I need to divide by 2 factorial. I've got the letter K that repeats 2 times, so I've got to divide out that 2 factorial. And I have 3 E's, so I need to divide out a 3 factorial. And that will give me a possibility of 151,200. All right, number 6, now we're going to do probability. Starting off pretty easy. It's just the probability of getting a king. Well, there are 4 kings out of 52 cards, and that reduces down to 1 out of 13. All right, number 7. What is the probability of choosing a marble from a jar? We've got 5 red, 6 green, 4 blue. So I want the probability of getting a green. Now, very straightforward probability problem. There are a total of 6 greens in there, and a total of 15 possible marbles. So you want to reduce that down to 2 over 5. The probability of choosing marble that is not blue. So the probability of, and I don't know if I said it before, but the tilde there is how you would say not. So not blue. There are 11 marbles in there that are not blue, because there are 4 blue marbles and a total of 15. So that's going to be 11 out of 15. Number 9, we're rolling a die, and I would like the probability of coming up with an odd number. Well, the 1, 3, and 5 are the odd ones, so that's going to be 3 choices out of 6 total different possibilities. So we're looking at 1/2. Number 10, I want the probability of choosing a jack or a queen. And as soon as I see the word or, I know that I'm going to be using the addition rule. So I'm going to be taking 4 jacks out of 52, adding that to 4 queens out of 52. Now the question is, can you be a jack and a queen at the same time? So do I have to subtract out any duplication? And no, these are mutually exclusive events, so they cannot occur at the same time. So I'm simply going to add those together to give me my 8 out of 52. And that's going to reduce down to 2 out of 13. Number 11. Landing on an odd number after spinning a spinner with 7 equal sectors numbered 1 through 7. So again, I want the probability of an odd number. There are 4 odd numbers between 1 and 7. And there are only 7 choices, and that's all there is to that one. Number 12, we want the probability of a jack or queen or an ace. So it's just your addition rule, just like we did in number 10 here. I cannot be a jack, a king, a queen, or an ace at the same time. Actually, it's not a jack, queen, or an ace. It's actually a queen, king, or an ace. There are 4 queens. There are 4 kings. And there are 4 aces. And there's no repetition to be subtracted out. So I got 12 out of 52, which should reduce down to 3 out of 13. All right, next is 13. We want the probability of choosing a queen or a red card. So that's the probability of a queen or red. And now these are not mutually exclusive, so I have to subtract out the duplication. So the probability of being a queen is going to be 4 out of 52. And add to that a probability of being a red card. That's half of them, 26 out of 52. But I've double counted any red queens, so I've got to subtract out 2 red queens out of 52. So that should give me 28 out of 52. Or 7 out of 13. 14, we're going to go A through F, and we're dealing with that chart that you guys have in front of you. We've got walk-in, TV, referred, not satisfied, neutral satisfied, and very satisfied. So we want the probability customer is not satisfied. You go over the first column, the total is 35 not satisfieds. And there is a total of 360 people in this. So that's going to be 7 out of 72. I didn't multiply these out on a calculator, but you certainly can do that. B, not satisfied and a walk-in. So you go to the not satisfied row, the walk-in column, and they are going to overlap. And there are 21 that are not satisfied and they walk in. And it's out of that same 360. And that reduces down to 7 out of 120. C, not satisfied, given referred. Okay, given referred is a conditional probability. I'm not dealing with the total 360. I'm going to go to the referred column, and the total of that column now is 149. So I've dropped down from 360 to 149. Now, in that column, I want to look for how many are not satisfied. That's the top choice. So it's going to be 5 out of 149. D, we've got a not satisfied. Nope. D, we have a very satisfied or. Well, as soon as I see or, I'm going to use my addition rule, or TV add. So very satisfied is the bottom row. There's 107 out of 360. Or, so I'm going to add to that TV ad. TV ad is the middle column, so that's 108 out of 360. But now you're going to look where that column and that row overlap. These are the ones that are very satisfied and TV ad. So we have to count those out of there. And where that row and column overlap, very satisfied and TV ad should be 31 out of 360. So that should give me a total of 184 out of 360, or 23 out of 45. E, we're going to be very satisfied given referred. Again, given, now we are a conditional probability here. So referred is the third column. Referred, then the total, that column is 149. And we want them to be very satisfied. That's the bottom row. So in the column of referred, there are 48 that are very satisfied. And that would be the last one, D, neutral or walk-in. All right, I can't be neutral. Oh, yes, I can be neutral and a walk-in at the same time. So I'm going to do the addition rule because it's an or here. So the neutral is the second row. There are 80 neutrals out of 360. I'm going to add to that the walk-ins. That's my first column. So that's a total of 103 in that column out of 360. But again, where that row and that column intersect, I'm going to have to subtract out the repetitions there. And that would be the walk-in column, neutral row, which has a 18 in that box. So I'm going to subtract out an 18 out of 360, which gives me a total of 165 out of 360, which reduces to 11 out of 24. All right, that was pretty quick going through that. Maybe it might be a little difficult for you if you don't, if I don't show it here with the paper, but you have it in front of you and going through it. If you need anything else, please let me know and I'll be happy to help you.